So this chapter, chapter 5, is called Polar Coordinates. Semicolon, awkward, and vectors. I've taken one physics class in my life and I try to forget about it because it was a horrible experience. But whenever we do get to the vector stuff, I'm going to look at you guys that took physics, and if you guys remember anything, will you guys just nod if it sounds familiar? Just because I want to see if you guys do know some things. Today is still the 9th. So in this chapter, you guys, or in this section, the first section is called just polar coordinates. You guys will learn how to plot points on the coordinate plane. That's a polar coordinate plane. So you guys will learn an entirely new graphing system in this section. Convert between what we call rectangular and polar coordinates, and then how to transform equations between rectangular and polar equations. So the first thing we're going to talk about is what is the polar coordinate system. And this is going to seem really weird at first, but it's not that hard, guys. I promise. Since middle school, you guys have practiced graphing points in the rectangular coordinate system. So plotting points in the quadrants, x, comma, y, right? That's what we call the rectangular coordinate system. We will now learn how to graph points in a new coordinate system using polar coordinates. So the way this works is in the polar coordinate system, we select a point P, which is called the pole. So not polar like it's cold, like polar bear. Polar because every point has what we call a pole. And then a ray with a vertex at the pole called the polar axis. Polar coordinates are not written as x, comma, y. They're written as r, comma, theta. Please know this. Where r is the radius or distance from the pole and theta is the angle. To draw these, we can start on the positive axis like we learned in chapter 2. Positive x-axis, excuse me. So the crazy thing is you guys already know how to graph these for the most part. You guys just didn't know you guys know how to graph these. So let's check it out. What does this look like? Okay, before you guys tape in this spider web looking thing, write down the directions with me and then tape in your graph, okay? So I want us to plot each point using polar coordinates. So what does our note say about polar coordinates? What's the parentheses say? R, comma, theta. Good. So you guys can go ahead and tape in that graph. So the first point we're going to graph is the point 3, comma, 5 pi over 3. Okay. So what I want you guys to understand is we can kind of treat this as, do you guys see how there's like a circle right here, a circle right here, a circle right here, and it keeps getting like larger and larger and larger as you guys go? I'll talk about what that means right now, but this outermost circle that we have on our graph, I want you guys to think about that as the unit circle. So what I'm gonna do is, and this is where students would get upset at me last year because I make you guys do this, I want you guys to label those angles, okay? So do you guys agree this would be 0? Okay, so this, you gotta be careful. The first angle on our unit circle is pi over 6, right? This is not pi over 6. What is this? 15. So you gotta be careful. This is 15 degrees. And the way that you know that is there's 1, 2, 3, 4, 5, 6. What is 90 divided by 6? And that's 15. So that's how you know that each one of these little, kind of looks like spokes on a bike tire to me. Each one of these little spokes is 15 degrees. So we're gonna skip this one, and I'm gonna call this right here pi over 6, which means that this would be 45 degrees or pi over 4. Then this one would be 60 degrees or pi over 3. Then if I add another 15 degrees, this would be how many degrees? 75. And then this would be 90 or pi over 2. So in general, I try to keep things like pretty straightforward for you guys as much as possible. If I give you guys these graphs, you guys are safe to assume you can skip the first and skip the last and just do the inner 3. Does that make sense? Label the inner 3. So we can skip this one, do those 3. Skip this one, do those 3, okay? So if you guys want, go ahead and start labeling the angles. Does anybody have any questions about the circle? Everyone's comfortable with that, hopefully, by now, right? It's our 4th trig chapter now. So, what does the 3 have to do with this? So if you guys look up here, what do you guys think that stands for? Radius, okay? So do you guys see how we have a bunch of circles? So if this was a 1, that means that you would use the first circle because the radius of this circle is 1. So since it's a 3, how many circles am I gonna use? Like from the center, how many circles do I have to go out? 3. So 1, 2, this would be the 3rd circle. Does that make sense? So that's gonna be my 3, and then I'm just gonna plot a point where it's 3 comma 5 pi over 3. So 5 pi over 3 is down here. So from the center, I'm just gonna count out 1, 2, 3, and just plot a point, okay? Now, because this is A, what I want you guys to do is once you guys draw your point, can you guys draw a capital A next to that point? Is everybody cool with that? All right, 3 comma 0. So how many circles am I gonna go out? 3. And then what's my rotation? To the right. Good. I'm just going to go to the right because 0 degrees or 0 radians, do you guys agree is 1, 2, right here? Does that make sense? So this would be point B. All right. C. So I'm going to go out 2 circles. What angle is the same as negative pi over 4? Good, 7 pi over 4. So it's going to be right here. All right, you guys look unimpressed, so I need to give you guys a hard one. Uh-oh. What do I do here? Okay, this is how I think about this. Where is positive pi over 4? Which quadrant? Quadrant 1. So if this was a positive 2, do you guys agree it would be like right there? All the negative means is, what do you guys think it means to do? What? Reflect. So the negative just means you're going to reflect across the origin. So, my bad, should be right here. So instead of being positive 2, I'm just going to reflect it over here, okay? So a negative radius means to draw the angle as normal, but then just reflect it across the center. So instead of it being right here, I'm going to draw it down here, right here. Is that right? Yeah. And this is point D. That looks like a P. So this is D. There we go. All right. So question, my smart friends. Question. What are other points I could use for D and land in the same place? So instead of negative 2 comma pi over 4 to get me there, what's another way I could do that? What's another r comma theta I could use? Two comma 5 pi over 4? Do you guys agree? Now, do you guys agree if I draw 5 pi over 4, that's going to be like that, right? Do I have to go that way necessarily? So what would the angle be if I went in the negative direction? Negative 3 pi over 4. So I could say 2 comma negative 3 pi over 4. What do we know about trig functions? They're cyclical, right? They have cycles. So if I were to go all the way around the circle and land the same spot, do you guys agree that's allowed? So what would I have to add to this number to go all the way around? 2 pi. So what would 5 pi over 4 plus 2 pi give me? What? 13 pi over 4. So what are you guys noticing here? Is there just one answer for this? Do you guys agree I could do that over and over and over and over again? So how many answers are there technically for each point then? Infinite. Isn't that weird? So that's what's different than like the graphing system you guys are used to. If I ask you guys to graph the point 2 comma 1, Hey, it's right there. Is there any other way to do that? I can't do anything else to get that point other than these coordinates. But for the polar system, there's infinitely ways to get there. That's weird, right? I'm not gonna do that to you guys. I'm just trying to show you guys and get you guys thinking that there is more than one way to do these. Okay? All right, cool. So knowing that idea, given point P with polar coordinates (3, pi over 6), find other polar coordinates r, theta, for which okay. So I didn't give you guys a graph for this one. So if that's not the case, this is how you guys can draw it like shorthand. Just draw like what would look like a normal XY axis. Which quadrant is this angle in? Quadrant 1. So what I'm going to do is I'm going to draw a radius like this, where the angle looks like it's about pi over 6. And then draw a point there and label it as 3, pi over 6, which means that this little radius right here, I'm just going to call length 3. So what is it asking me to do? What it's asking me to do is I want to come up with another series of x and y, r and theta, to where it's going to land in the same place, but theta is now between these numbers. So what can I do to this number to get me there? Add 2 pi. So all I have to do is just add 2 pi, because then I would go all the way around and land in the same place. Okay? So pi over 6 plus 2 pi is the same thing as pi over 6. If I get a common denominator, this would be 12 pi over 6, which will give me what? Yes, 13 pi over 6. So another possible answer for this would be r theta is equal to, what was my radius? 3, comma? Yes, 13 pi over 6. Cool. B. So what is this saying about my radius? My radius is now what? Which means it's negative. What did we talk about in the last example when the radius was negative? What did we really do across the middle? Reflect. So what I want you guys to imagine is, okay, my goal is to be here, right? This is my goal. So my radius, I need to pick a radius and angle to where it's going to reflect in backwards across the origin right there. So in other words, your radius, the radius they gave me was +3, right? So our radius now is going to be -3. But what is the angle I have to pick so that way it's mirrored across the origin and will get me back over there? 7 pi over 6, because it's basically half the circle away. Does that make sense? So if this is, we want pi over 6, so then if I pick -3, 7 pi over 6, because the radius is negative, it'll kick me back over there. Because that's my goal, is I want it to be in the first quadrant. So my angle I have to pick is 7 pi over 6. Okay, questions? All right, so this is just a technical way to do this. So just taped in this box. So next thing you guys are going to learn, and this is something that, guys, we're honestly going to use for almost every section of this chapter. How to convert from rectangular to polar form. And I'm hoping that if and when any of you guys do take calculus 2, it'll be where I'm not your teacher guy, I'm not your guys' teacher anymore. Hopefully you guys remember learning this if you guys ever do see it. All right, in the figure shown, we can derive the formula to convert from rectangular coordinates to polar coordinates. So before in the box, I want you guys to write the formulas when I teach them to you guys. So what I want you guys to look at is, let's look at this picture. Let's say I wanted to figure out what y is. So from theta's perspective, what side is y? Opposite or adjacent or hypotenuse? Opposite. And which side's the hypotenuse? R. So do you guys agree from this picture I could say that the sine of theta is equal to opposite over hypotenuse? Now remember that polar form is r comma theta, right? So how would I get y by itself? Multiply both sides by r. So that means that y is equal to r sine of theta. Can you guys put a box around that? Okay, so now we can do the same thing for cosine. So what could I write about cosine using this triangle then? Cosine of theta is equal to X over R. So do you guys see how here I have no X's and no Y's? This is why this is important. So how do I get X by itself? Multiply both sides by R. So that means that X is equal to R cosine of theta. So this means that we have our formulas. X is equal to R cosine of theta, and Y is equal to R sine of theta, where, how could I solve for R? Yeah. Do you guys agree that X squared plus Y squared is equal to R squared? How could I solve for R? Square root. So that means that R is equal to the square root of X squared plus Y squared. Isn't this cool, guys? You guys are coming up with all these formulas using stuff you guys already know. So it's like we're being like little mathematicians and proving things right now on our own. Now let's pretend like we don't know R. How could I figure out theta? If I know Y and X, which trig function could I use to find theta? Tangent. Hooray. This box is really important. Everything we're going to do for this section, next section, pretty much till 5.5. You guys need to know this stuff. 5.6 is when we go on a tangent. And we go into 3D. You like that? So then things get a little different, okay? All right. So let's use this. Now, if you guys are going to get confused at all in this section, in this chapter, it's understanding what you're actually finding. So let's talk about this. Find the rectangular coordinates of the points with polar coordinates colon. Now, this is your guys' first time seeing this, right? So I don't expect you guys to be experts right now. But do you guys agree that we don't write them the same? What is the coordinates, like the whatever, comma, whatever? What's that for polar? This is R, comma, theta. Polar is R, comma, theta. So what is rectangular? This is X, comma, Y. So when it says find the rectangular, that means you need to find X and you need to find Y. Okay? Now this is pretty straightforward too, because watch. The point I'm going to give you guys is 6, comma, pi over 6. So just thinking back, let's just think back to like freshman year. Would you guys ever graph this freshman year? Or 8th grade? No. So this means that this already is in which form? Polar or rectangular? Polar, because this is an angle. Does that make sense? So I need to figure out what X is, and I need to figure out what Y is. So according to my notes, what formula do I use to find X? X is equal to R cosine theta. So this is R, and this is theta. All I have to do is plug it in. And there should be no excuses, guys, because guess what you have on your tables? A calculator. So on a test, please don't get these wrong. Now this is important though, because watch what's going to happen right here. X is equal to r, which is 6, times the cosine of pi over 6. So just using your unit circle knowledge, guys, what is the cosine of pi over 6? Square root 3 over 2. So let's say on a test you guys forget that. Can you guys put that into your calculator real quick? What is the cosine of pi of 30 degrees? And I want you guys to see that it's 0.866 and it keeps going. Please, if you guys don't have that memorized yet, please learn that, because that is the square root of 3 divided by 2. So if you guys see that decimal, you guys know that that's that. Does that make sense? There's only 3 or 4 decimals you guys really need to know on a unit circle. And this is one of them. And this is how I got through trig and PreCal. Because I can tell this to you guys now. My teacher never made me memorize the unit circle. I know my shoe's untied. It's fine. My dog messed up my shoelaces, so my shoelaces are messed up. I need to get new ones. And shoes on my shoes. But my teacher never made me memorize this, so I had to memorize all the decimals. And that's how I was able to get through calc and PreCal. So if I simplify this, guys, what happens to the 6 and the 2? It cancels and becomes... This is awkward. What's my answer, guys? Thank you. 3 square root 3. Hey, I could do the same thing for sine. Y is equal to what? R sine of theta. So y is equal to, our radius is still 6, times the sine of pi over 6. What's the sine of pi over 6? 1/2. So that, what is that? 3? So it says find the rectangular coordinates. So how would I write my answer? X comma y is equal to 3 square root 3 comma 3. When you guys take your quiz in chapter 5, this is how your quiz is going to be. Literally just show me you guys know the formula. Okay, let's do a harder one. But more fun. Okay. If students missed questions in this chapter last year, it's because they forgot to kind of visualize what's happening. So let's kind of think about what this would look like. Where is negative pi over 4? Which quadrant? Quadrant 4. So do you guys agree it would look something like this, where I could say that this is 4? But my radius isn't positive, right? It's actually negative. So if I reflect this across, where is this point actually drawn? Which quadrant? Quadrant 2. So this is quadrant 2. Now, this is important because which quadrant were we in for part A? 1. What do we know about every point graphed in quadrant 1? Everything's positive. So this is a kind of a way to check yourself before you wreck yourself. You can check your answer. So if I'm in quadrant 2, what for sure should be negative, X or Y? X. Check your answers, guys, because this will help you guys get it right. So X is equal to R cosine of theta. So x is equal to my radius, which is -4, times the cosine of negative pi over 4. Now let's see how much you guys remember. Cosine of a negative angle. What do we know about cosine? Is cosine even or odd? Cosine's even, so do we care about the negative? No. Good. So this is the same thing as -4 times the cosine of positive pi over 4. What's the cosine of positive pi over 4? Square root 2 over 2. So if I simplify this, I'm going to get -2 square root 2. And if I'm just using my brain and thinking about this, okay, well, based off my picture, is this accurate? Yes, because x is negative over here. So then y is equal to r sine of theta. So it's going to be -4 times the sine of negative pi over 4. So we know cosine's even, sine is odd. So do you guys remember for a sine function, what does that really mean about if it's odd? Where can I replace the negative then? Do you guys understand what I'm saying? Okay, let me use better words so I don't teach English. If a function's odd, you guys agree negative f of x is equal to, f of negative x is equal to negative f of x? So that means I can really put the negative right there, right? And then what's going to happen to the negatives? They cancel. Okay, so this is the same thing as just 4 times the sine pi over 4. And again, like, yes, does that help you to know that? But what do you have on your desks in this chapter? A calculator, so you guys can just check your math. What's the sine of pi over 4? Square root 2 over 2. So if you're taking my advice, learn this decimal. It's 0.7071. So that's how you guys can remember it's root 2 over 2. So this is 2 square root of 2. Okay? Do my sines, not this sign. Do my sines match? Yes. So where I'm supposed to be. I'm supposed to be in quadrant 2, right? So my final answer for this problem is x comma y is equal to -2 square root 2 comma 2 square root 2. Questions? Okay, now let's go the other direction. Nope. So this is where things get a little bit tricky, and I need to make sure I kind of don't catch you guys slipping here, and make sure you guys are staying on your toes. This first one's actually pretty straightforward, because what I want you guys to think about is, first of all, if I'm given this, how do I write my coordinate then here? This is x comma y. So I'm finding what? R comma theta. So right now, I don't know R and I don't know theta. So can you guys see how this can kind of be confusing? Because a radius could be 0. That'd be kind of boring. An angle technically could be 3. That's kind of weird though. But it could be. If I were to plot 0, 3, is that in a quadrant or on an axis? On an axis. So do you guys agree that would be something like that? So do you guys agree that this right here means our angle is pi over 2? Is everyone cool with that idea? Now, let's say we didn't think about it that way. We have a formula. Theta is equal to what according to our box? Tangent inverse of y over x. So if I do this, what would go on top? 3, and what will go on the bottom? What do we know about this fraction? It's undefined. And if you think about the unit circle, where's tangent undefined? It's at pi over 2 and 3 pi over 2. But since my point is up, that's why it has to be pi over 2. Okay? I'm going to put just sad face. Okay. So we're not done yet because we have to find r. What's my formula to find r? Good. Square root of x squared plus y squared. So r is equal to the square root of 0 squared plus 3 squared. So r is equal to 0 squared is just 0. So the square root of 9, which is 3. So what are my coordinate points? Three comma pi over 2. Good. Say 3, 0. It's okay. I forgive you. Just don't do that on a test or quiz. All right. Go ahead and just write this down, and we'll pick up here on Friday.